Alright guys, I got a quick lesson for you today, and I apologize if there's loud sounds in the background. I am in the hotel trying to record this for you, so I do apologize. Today we're going to take a look first at what is direct variation. And direct variation, basic idea behind it is a linear equation, just like we've been looking at in this chapter. We've been looking at things like y equals mx plus b. The only difference with direct variation is that it is not a function that has a beginning amount. So it's basically just the first part of that y equals mx plus b. It is just the y equal to a constant number times x. They call this number the constant of variation, and sometimes you'll see it represented with a letter k instead of an m. That doesn't change what it is. It is still the slope. It is still the slope times the x that gives me the y value. So an example of this, kind of in a real life context, would be the points that you score from 2-point shots in basketball is directly related, notice that word directly related to the shots that you make. So in other words, if you were talking about this situation in an equation format, the points that you score is equal to 2 points times the shots that you make. Yes, I realize that there's more than 2-point shots in basketball, but that's an example of where direct variation comes into play. Another example, real life, if you wanted to, the money that you make at McDonald's is equal to 7.25 minimum wage times the hours that you work. So that is an example also of direct variation, where you have a constant number times your input that gives you your output. So how do you know if you have something that has direct variation? Well, number one, the easiest way is it's told to you. You have something like the words direct variation in the problem, or varies directly. You see that right here, vary directly in the problem. Or it is a little bit tougher, but sometimes you just know by the situation. You know that if you multiply $7.25 times the hours that you work, that's the money that you make. So sometimes it's just a natural thing that comes about because of the real life context that we're talking about. Sometimes the problem actually has the words in it, direct variation, or varies directly, something like that. But like I said, it's basically the same idea, the things that we've been working on over the past week. When we were talking about y equals mx plus b, we were talking about the slope-intercept form of a line. The difference is this one doesn't have a y-intercept. Now let's talk about real quick why it doesn't have a y-intercept. Why does it not have a b value? Well, think about this. In basketball, if you don't make any shots, you don't score any points. So 0, 0 would be a point on your graph. Or in other words, your beginning amount would be nothing. Same thing if you're working at a job. If you work 0 hours, you get $0. So that is the same thing. That is the point that is right in the middle of the graph. No y-intercept there. So your beginning amount, where you begin your graph, is always 0, 0. Let's look at that physically on a graph with a couple examples real quick. So let's say you have y equals, let's do that, y equals, here we go, y equals 2x. So y equals 2x. Notice there's no beginning amount, so that means your graph would go through the origin. Your slope, your m, is 2, so it would move up 2 over 1. So you go up 2 over 1, up 2 over 1, up 2 over 1, and you get this graph that goes through the origin, and it has a slope of 2. Notice your constant of variation, y equals 2 times x, this is like we talked about with the basketball example, is your slope. And notice that your graph goes through the origin. I know my line's just a little bit off there, it's okay. It would work the same if it was a negative 1/2 x. Notice that that's a negative 1/2, but my beginning amount is still 0. So I go here at 0, put a point. My slope is negative 1/2. I go down 1 over 2, down 1 over 2. And so my m is my constant there. So guys, when you are looking at these equations, it's just a simpler version of some of the things we've been looking at because There is no beginning amount. Their slope is basically staring you right in the face. But I also want to point out something as we look at these points. If you look at this point right here, this is the point 1, 2. If you look at this point right here, it's the point 2, 4. Notice that the y values in those points are equal to 2 times the x. That's the whole reason it's called a direct variation problem. The y value is directly related to what x is. There is no adding that's involved. There's no extra operation that we have to deal with. It is just y equals 2 times x. The same thing would apply for this one over here. If you looked at this point right here, this is the point 2, negative 1. This point right here is the point 4, negative 2. Every y value is negative 1/2 times the x that we had. So that's why it's called direct variation. So direct variation is when you have a constant number multiplied by the x to get the y. Again, that number though is just the slope. And again, because it has no beginning amount, that means these graphs all pass through the origin. So these two little things at the bottom here are pretty key little points about the graphs. You can pause it and copy these down if you would like, but it's all of these graphs pass through the origin. Their beginning amount is 0, and the slope of these lines is the number multiplied by x, or the k, the constant we call it. Now again, guys, I don't want you to get too confused over the fact that it is a k there. It's still the same thing as mx plus b, the same thing. So the final thing that we're going to do with these is be able to actually come up with the equation if we know there is direct variation, because that's what we've been doing in this chapter, is writing the equation. So we're going to take a look at this sentence. It says the variables x and y vary directly. When x equals 5, y equals 20. I'm going to show you a long method first. First of all, we know if we need to write the equation, we need the m and we need the b. The problem is we already know the b is 0, but the m is not given to me because I don't have slope is anywhere in the sentence. So that means I've got to find the slope. But because the b value is 0, we know that the origin would be one of the points, and 520 would be the other point. I'm going to show you this long method, but I'm going to show you a shortcut. If the slope is y2 minus y1 over x2 minus x1, the y value minus the y value, the x value minus the x value. Again, the reason we knew this is because they always go through the origin if it's direct variation, and 520 is the point that was given to me. What is 20 minus 0? Just 20. What is 5 minus 0? Just 5. 20 divided by 5 is 4. Notice right here that if I know that this point is going to go through the origin, I can just basically drop off the 0 and the 0 and just do this y value divided by this x value to find my slope. And guys, that will always be the case for direct variation. So that means my equation would be y equals 4x plus nothing. Don't put a plus b because the b is 0. So it's the same thing that we've been doing all week last week. The only difference is finding the slope on these is actually really quick because all you got to do is find y divided by this x, because every point, the y value is equal to the slope times the x. So the second part of this question says find the value of y when x is 10. That just means take your equation that you found and use it. So y equals 4 times 10. 4 times 10 is 40. That is my new amount. And guys, this will be the same thing that if you were using that equation we talked about for the money that you're making at McDonald's, and you plug in a number of hours that you work, multiply by $7.25, you would get the money that you make. And so it would be the same concept. That's all I'm doing is just plugging in a number for x to find a y value. So that means 1040 would be another point if I graphed this thing. All right, let's do another one. Try this one on your own. pause the video and try it on your own before you watch the solution. So x and y vary directly. So again, I say direct variation right here. So that means I'm looking for that little y equals some constant number times x, or y equals mx with no b. So notice again, there's the little shortcut that I showed you. All I have to do to find the slope for this one is actually take the 39 for the y divided by the 13 for the x, because that is what's going to happen if I had the minus 0 and the minus 0, because these always go through the origin. So you can save yourself a little bit of time and do a quick little shortcut here. 39 divided by 13 is 3. So my equation would be y equals 3x plus nothing. Again, remember, there's no b value. So it's just y equals mx. These are only direct variation, okay? So don't get all caught up in doing this when we do the other ones. You still need to remember how to find the b value for the other ones. Then it says find the y value when x is negative 5. So we're going to plug in negative 5 for x. 3 times negative 5 is negative 15. You could also do it the other way around. You could find the x value if you plugged in a y value also. You would just have to divide the 3 over to find x. All right, let's look at another example, and this will be our last example. It says in 1852, Henri Giffard built the first airship successfully used for transportation. It had a volume of 88,000 cubic feet and could support 5,650 pounds of weight. The Graf Zeppelin II, this is what you guys, any of you that are into music, know what the Led Zeppelin is a play on the words, the fact of a Zeppelin that's falling to the earth, which is a big, basically a blimp. And it's a little different, but basically the same idea. The Graf Zeppelin, built in 1937, had a volume of 7,063,000 cubic feet, making it one of the 2 largest airships ever built. The weight an airship can support varies directly with its volume. There's the clue. The weight varies directly with the volume. That means the weight is equal to some constant times the volume. Or you could also look at it this way. The volume that it can hold equals some constant times the weight. Now typically, we were trying to figure out how much weight could the Graf Zeppelin support. That means we're actually probably going to use this formula instead of the volume equals, because we're not trying to figure out the volume. We typically know the volume that it can hold, so that's our input, and the weight that it can support is the output. So, how do we figure out what the actual amount is? Well, we do have the one that Henri Giffard built, 88,000 cubic feet is the volume, 5,650 is the weight that it supported. So what I can use is I can use the weight, 5,650, that it supported, equal to the constant times 88,000. I can use this little formula to find the constant. I can also use what we talked about over here. Remember where I told you I took the y value divided by the x value to find the constant. The y value divided by the x value to find the constant. Same thing here. I can take the y value divided by the x value to find the constant. Now, in other words, remember, that's the same thing as my slope. That's the same thing as m. Okay? So, I just take out my handy dandy calculator. Alright, so let's switch to the calculator real quick. I should have already had it open. That would have made this a whole lot quicker, a whole lot easier. But it'll just take a minute. So for our calculator, we take out, you can use Desmos if you want to also. And I'm going to do 5,650 divided by 88,000, and that's going to give me my slope, or my constant. Notice this constant here, this slope is a little different. It's an ugly decimal here. You could use the decimal, or you could hit math, enter, and change that back to a fraction. It's not real pretty, but I would probably tend to use the fraction. I would use 113 over 1,760. Now here's the reason that I would use the fraction. That's my slope. So y equals 113 over 1,760. Number one is the slope. So if I was thinking of graphing, I could do this. But granted, that would be a gigantic graph. Here's the reason I would really use the fraction. I would really use the fraction here because what that does is that gives me a very exact answer, and then I can be a little bit more lenient with it if I was actually building this ship. Now, I know you guys are probably not a lot of you are going to go out and build blimps or zeppelins, as they're called, but it's just an example. If this happens in a real life situation, it's usually more precise to use that fraction instead of going through and using that little ugly rounded decimal. So what we could do now is take this little guy here and take this ugly fraction times 7 million to figure out 7,063,000, how much the Graf Zeppelin would support. So we take this fraction here and we multiply it by 7,063,000, and that gives me, it would support 453,476.7 pounds. That's where it would be okay to write it out that way. So I'm going to highlight, this would be my equation that I got, and 476.7. That's how many pounds this particular Zeppelin would support. And so then you could have a passenger ship. If any of you have ever watched any of the Indiana Jones movies, there was a little blimp in one of the Indiana Jones movies. I believe it was Raiders of the Lost Ark, if I'm not mistaken. I might be wrong on that, and it shows the people sitting in a big carriage underneath. When you watch football games, they have the blimp with the little carriage underneath, and the people fly around and video the games. That's what we're talking about. It could support that much weight with that much cubic feet of air inside it. All right, so your homework is right here on the screen. Oh goodness, right here on the screen. All you have to do is go through, do the problem at the top here, and then the 4 problems at the bottom. So it's only 5 problems. Again, sorry guys, I just didn't think driving from Kentucky I could do WebEx while I was driving down the road. So I thought it would be better for me just to give you a lesson on this through YouTube instead of driving down the road trying to do WebEx. So good luck, guys. If you have any questions, I can be on maybe later tonight. And tomorrow when we get on together on WebEx, I will make sure to answer questions then. See you guys.